Hello students, and welcome to lesson 2.1. Today we're going to be taking a look at our trigonometric functions and using our calculator to do approximate values. So we're going to be doing rounded values here. So just want to do a review of what we did in our first lesson. So we looked at SOHCAHTOA, our mnemonic for remembering the sine ratio, cosine ratio, and tangent ratio. Sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent, so our SOHCAHTOA. So what we're going to be doing now is we need to find out, well, what is the approximate value of sine of 35 degrees, the approximate value of cos of 35, and the approximate value of tan of 35. So just remember that anytime we're using an approximate value, we're going to put a little dot above the equal sign. So it just tells us that we're using an approximate value rather than a strict equality here. So let's take a look at our very most important asset, our calculator. So if you've got the Sharp Scientific that I've recommended, I want you to take a look at it. Hold it in your hand and take a look just to the right of the second function button. You're going to see a button called DRG. So if you press that a few times, you'll notice that in your input screen you've got it cycling between deg, rad, and grad. So those stand for degree, radian, and gradient. You can ignore radian and gradient for grade 10. We're going to be focusing on degrees. So always make sure it's in DEG mode, please. So what we want to do here is let's grab our calculators and we want to find out what's the sine of 35, the cos of 35, and the tan of 35 accurate to 4 decimal places. So rounding to 4 decimal places. So pause the video and give that a shot. Okay, so what we get is the sine of 35 accurate to 4 decimal places is approximately 0.5763. The cos of 35 degrees accurate to 4 decimal places is approximately 0.8192, and the tan of 35 degrees accurate to 4 decimal places is approximately 0.7002. So what I want you to do now is we're going to try the same thing, inputting now the degrees of sine of 58, cos of 58, and tan of 58. So pause the video and give that a shot. Okay, so what we find here is we get, for the sine of 58 degrees, we get approximately 0.8480 accurate to 4 decimal places. We get the cos of 58 degrees is approximately 0.5299 accurate to 4 decimal places. And the tangent of 58 degrees is approximately 1.600 accurate to 4 decimal places. So thankfully we have our marvels of technology allows us to, rather than looking up on this huge chart and booklet, our calculator can quickly and efficiently tell us what the ratios for given values are. So it makes it a lot more efficient than it was in the olden days. So what we want to do now is we want to take a look at what's really going on. So kind of trends in growth and decay, I guess you could say. So let's take a look here. Now, the angles that we're looking at as far as grade 10 is concerned, your angle X is bound between 0 degrees and 90 degrees. So it's strictly greater than 0, but strictly less than 90. So take a look at what's happening here as these values change. So we've got hypotenuse, we've got opposite, we've got adjacent. We're going to go back to our SOHCAHTOA measures here to help us out. So let's see. So remember that sine is simply opposite over hypotenuse, and cosine is adjacent over hypotenuse. So what's actually happening here? Well, as we see, as your degree gets larger, your opposite side gets larger, and as your degree gets larger, your adjacent side gets smaller. So what we have is, as your angle gets bigger, sine gets closer and closer to 1, and as your angle gets bigger, cos gets closer and closer to 0.